There it goes.
Live.
Just takes it a minute.
Yeah. So
the first two questions are just the, did you participate and did you do the preparation stuff?
Yeah. And I think the hold on. So I think it's a null hypothesis is number 3.
That involves equality. Yeah.
Yes.
Sorry.
And I'll go ahead and read so you don't use your jaw.
Thanks.
Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. All of these terminologies just drive me crazy. So the question is, when computing the p-value, which hypothesis do you assume to be true?
The null hypothesis?
The null. Yeah. And the last thing I read was, you never say that you accept the null hypothesis. You say that you
fail to reject.
Yeah.
Fail. You have to do it backwards almost.
Mm-hmm. That confused me in itself.
Yeah.
Until I figured out what exactly that meant.
Yeah.
The word fail to reject. I don't know.
Well, a null hypothesis is confusing too because it's not what we think
Mm-hmm.
null would normally mean. Okay, number 5. Which of the are we on 5?
Yeah.
Yes.
Which of the following represents the alternative hypothesis for a two-tailed test?
That would be C.
Not equal to.
Yeah.
Yeah.
That took me a while too to figure out what the different tails were. I was like, huh? Where did I miss that?
And the scary thing is that the exams that we have are cumulative, so we have to remember all this stuff from the very beginning when we do our.
I wonder if we can use like our notes for each exam and put them to the next exam. That would be nice.
I'm hoping.
Okay. So
okay, number 6. Which of the following represents the alternative hypothesis for a left-tailed test?
That would be A.
The smaller than.
Less than. Mm-hmm.
Yeah.
Okay, 7. Which of the following represents the alternative hypothesis?
Right-tailed.
B. Right.
That'd be greater than, wouldn't it?
Mm-hmm.
Yeah.
B.
Maybe Jennifer, you read them because my computer's being really slow, so I'm not able to move them.
Okie dokie. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or I guess that's sigma, right? A. Use this information to answer the next 2 questions. So for 8, which relationship would result in failing to reject the null hypothesis? That would be, what the heck is Z in there for? It would be B, right? P-value is negative or is less than A.
Let me double check. If the P is low, reject the null. So yeah.
Why is there Z there? That has nothing to do with it. Is it trying to throw us off, I think?
I think it is.
Because that's a
well,
Z.
at some point you do use the Z-score, but I think it is just trying to throw us off.
Yeah. Okay. 9, which relationship would result in rejecting, isn't that the same question, the null hypothesis?
In failing to, so it'd be A.
Yes.
And then the next one is.
See, it's all these words. Failing to reject, so 8 is A and 9 is B.
Yeah.
Well, wait, 9 is, yeah, B. Okay. 10, an insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim was 1,500. They are concerned that the true mean is actually higher than this. Use this information for the next two questions. Which of the following would be the appropriate alternative hypothesis? So, the average rate was 1,500.
Yeah.
So that's our hypothesis, and it wants to know if it's higher. So then it would be the greater than 1,500.
Mhm.
So it would be the average claim amount is greater, so C.
Yeah.
Is Linda still with us, or did we lose her?
I'm here.
Oh, okay.
I'm just trying to keep my computer up.
Are you getting all of
I'm
this?
good. Yeah, I'm good.
Okay. For 11, which of the following would be the appropriate null hypothesis? The average claim amount is equal to 1,500, A, right?
That's what I thought.
Mm-hmm. Okay, for the next one, the insurance company randomly selects N equals 40 claims and calculates a sample mean of 1,650. Use this information to answer the next three questions. The insurance company assumes a distribution of the sample mean is normal. Is this a good assumption?
And this is where I thought we had one like that.
Oh, is it because the sample size is large? Because the sample size is larger than 30, which means it's a large sample size.
Yeah.
So
I thought it
the
was
first
A.
one,
Yeah, that's what I think it is too. What theorem or law justifies your answer to the previous question? All right, Linda's I call you the expert on this. But it's the size, so it would be the law of large numbers?
that one covers how far apart they are. The mean and the standard deviation. Is that right? Central limit theorem is what the thing looks like.
Yeah. But because the sample size is large, that would make it the law of large numbers?
That's what I think.
It should, yeah.
Okay. 14, which of the following is a test statistic as defined in this lesson?
I thought it was X.
Which one is X? Isn't that the mean of the
Oh,
sample?
right. That's the mean.
The
Right.
test statistic? Is that,
Test statistic.
is it N?
That's the
I'm thinking,
size.
oh,
N
that,
is a
so
size.
that would
So it's
be
S.
statistic, yeah. S is the sample size.
Is it?
I thought N was the sample size.
N is a sample size.
Isn't N the,
And S is the standard deviation. N is the sample size, like the number of people in the sample.
standard deviation is our 0 with the line.
Oh, X. Sorry, X was the line. Yeah, you're right.
I think it's S. Because all the other ones, we know what they are.
Yeah,
Okay, so 14 would be D.
I see. See, some of this stuff is just not in the.
That wasn't in, yeah, I don't know what S is.
The test statistic? Let's see what it is.
S. I don't think S came up in the reading at all.
Oh, it's Z. I think it's Z. When I just Googled it, let me see. It says test statistic and then it has the Z symbol, which is the
And
Z score.
And that's used.
Yep. So it is the second one. That would make sense because that's, and then we put that number into the applet. Okay, that
And get
makes
the
sense.
probability.
Yeah.
Mhm, exactly. All right. The historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypotheses. So we have the null and the alternative. She will use a level of significance of A or sigma, which is 0.05. She then takes a sample random sampling of 36 sales receipts from her store and computes the mean of 144. Use this information. So we need to know what the z-score is for this.
And this is where I had issues. I'm like, how do I do this calculation? I know I've done it before, but where does everything go?
Right.
Okay, so the sample mean is 144 minus the mean, where's that?
It's 150.
150. Mm-hmm.
Or she said that she had there was another one.
That's
the end
the,
of-
she will,
Let me,
okay, what other one are you referring to?
sorry, just a second, I'm getting to it. Oh, you said it was the 144?
Yeah, because that's the sample mean
Okay,
divided by the mean, the population mean, and the population mean is 150.
So you're dividing 144 by 150?
You're taking 144 minus 150
Okay, yeah.
and dividing that by the deviation, which is,
0.05, but there's also a random sample of 36.
that's not, okay, 0.05 is not the deviation. The deviation
40.
is 40.
Oh, you're right. Okay.
Divided by the square root of the sample size
is 36.
is 36. So that 0.05 sigma, that is the number that we compare the other number to. So we don't need to do anything with that other than compare.
So what's the z-score associated with this test? Let me do that.
So we need to calculate it.
Yeah.
Do your children, oh, you don't have children in school, do you? Never mind.
No,
I do.
They text me all day long. I'm like, aren't you supposed to be learning or something?
Yeah, my daughter's not allowed to take her. So I got negative 0.45.
I'm almost there.
Let me know if.
I got 0.90, and I don't know if I did it right. Minus 6.
I got negative 0.900000.
Okay, that's what I got.
.9.
I lost you guys. What'd you guys get for the z-score?
0.9000.
How did I do that wrong?
And we want to know.
See, I got
Okay.
I got 0.45 for the z.
So you take the 144 minus 150, that gives you a negative 6 on top.
Mm-hmm.
And then,
I know what I did wrong.
okay.
I put 147.
Oh.
I don't know why I did that.
So our answer is going to be negative 9.0,
So I got
round to 3 decimal places, 00.
I got 0.9. Is that what you guys got for the z-score?
Yeah.
Yes.
So negative, I mean.
0.900.
Is it negative?
Yes, that's what I got.
Because you're subtracting 144 from 150.
Yep. So you're gonna have a negative on
Okay.
top. And then the p-value, when we put it in, we want to know has decreased.
And so what's the p-volume? Is the p-volume,
So go to your applet and put in the z-score of 0.900, and we're going to shade to the left of the negative 0.900, and then that area is our p-score.
0.1841?
1841.
So 0.184.
See how it says in parentheses round to 3? Like if it would tell me
Yeah.
that, it would make my life so much easier on that test.
Well, and that's something that could be suggested to the teacher for the committee to take care of.
Okay, what inference would you make about the null hypothesis? So the z-score, this is where we compare it to the 0.05. So this is greater than the 0.05, which
But
makes...
the z-score was a negative, so it's not greater, it's less than.
No, not the z-score. We don't care about that. We care about the score in the top of the applet.
Oh, the p-score.
Probability.
The p-score, the area.
Okay.
So that 0.184 is greater than 0.05. So that means that it's true. The null hypothesis is true. So I don't know how to, whatever terminology.
We failed to reject the
failed to
no. Right.
And then 18. What is your conclusion for this problem? Let me see. We have sufficient evidence that the true population mean is 150. We have sufficient evidence that the true population mean is less than 150. We have, I think it's D, right?
Yeah.
Mm-hmm. This is 18. And then 19, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I hate this. So which test involves rejecting the null when the null hypothesis, type 1 error?
Okay, I wrote all that down.
You're rejecting it, but it's true.
So is it 1 or 2?
I think it's 1, but it could be wrong. I've been struggling with this one. Type 1 is you reject the null hypothesis when it's true. Type 2, I have you don't reject the null hypothesis when the alternative is true.
And we failed to reject the null hypothesis for this.
But it's not asking us about that one. It's just asking us in this question. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? So type 1 would be
Yes. That's how my definition reads.
okay. And then 20, how many questions are there? Gosh.
21.
Okay. A researcher decided that instead of using a level of significance of A equals 0.05, he will use A equals 0.01. Which of the following will be true?
Instead of
The
using
probability
a
of
level,
type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease. His experiment will be more scientifically valid. I think it's C. The probability that the null hypothesis is true will decrease because it's a lesser value than 0.05.
Mm-hmm.
Because you don't know the error, the type 1 or type, I don't know. That's what I think. I think it's C.
That's what I had. That's what I typed.
Okay. 21, if A equals 0.05, compute the probability of committing a type 1 error. I don't know how to do that.
Oh, did they show us?
Yeah, I remember seeing it somewhere.
Okay. If A value.
I don't remember seeing how to figure this. The probability of committing a type 1. Do we have to figure the z-score with that?
No, we just need to know the probability. I want to say it's 0.05. Okay, here we go. Google's my friend. If the significance level for the hypothesis test is 0.05, then use confidence level 95% for the confidence interval. Okay.
So is it 0.01?
I have no idea.
I don't either.
Because 0.95 would round to 0.01 and 0.095.
Yeah, I don't know if that's right, but I don't know.
When looking, it's on section 5, perceived health after a cardiac arrest. I think I'm on the right. 4.6. Yeah. No, sorry. It's not. That's not where it starts. Type 1 and type 2 errors in the homework. It says whenever we reject a true and null hypothesis, we say that a type 1 error was committed. Assuming the null hypothesis is true, the level of significance A is the probability of getting a value to the test statistic that is extreme enough that the null hypothesis will be rejected. In other words, the level of significance A is a probability of committing a type 1 error. It can't equal 0.
Does it say how to compute it?
Well, it says we chose A to be some small number so that the probability of committing a type 1 error is low. The most common value for A is A equals 0.05. This is equal to 1/20th. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of a significance. Other common choices for A include 0.1. That's all it says.
Read the sentence before that.
The most common value for A is A equals 0.05. This is equal to 1/20th.
Maybe it's in that.
Because they want us to compute the probability.
Right.
In our preparation, if you go to part 2, question C, or 9C, it says if the analysis was done at the sigma of 0.01 level, what is the probability of committing a type 1 error? So the way that he explained it was you do 1 over 100 or 1%. So if it's 0.05, would that be 5 over 100?
Or 5%.
Because what's 1 over 100?
1 over 100 is
0.01. So
1%.
So if it's 5 over 100, it would be 0.05. So would it be 5%?
It should be 5.0, or no, 0.5, no, 0.05.
So it'd be the same number. Can we try that?
Yeah,
Yeah, that's the only thing that comes close to making sense.
I'll submit it real quick. Let's see where we're at. So we got that one right. We got 20 wrong, which is question 2. So it was with the probability that the null hypothesis will decrease. We got 18 wrong and 13 wrong. It's not the law of large numbers.
So is it the central limit theory?
So which ones, we got 13 and 18 wrong?
13, 18, and 20.
13. So is it the central limit theory? Because I don't think there's a law of total probability, is there?
No, it's
It's
I
got,
never, no, there's not a law of total probability.
it's got to be CLT.
Yeah.
Hold on, there is a law. Oh, wait. I'm Googling it and something came up. Okay, so we think it's the central limit theory.
Mm-hmm.
Okay. So then 18.
What is your conclusion?
So
I
the average has decreased. So what do we put? We have sufficient, because we have sufficient evidence that I guess maybe it's that the population mean is 150.
Yeah.
Oh, because that's what the hypothesis stated, the null hypothesis.
Yeah. Let's try that one. And then 20 is, a researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? We said that the null hypothesis is true. The probability that the null hypothesis is true will decrease. His experiment will be more scientifically valid.
This one's
It
hard.
never indicated that with the, if you changed it, it said the most common is the 0.05. And then sometimes they use that at those smaller ones.
So we're decreasing, right?
The p-value.
The probability. No, we're increasing, the level of significance. Is this the one that if you no, you decrease one, the other one goes up? Increasing the sample size, oh, I don't know.
If the p-value method, if the p-value to your selected number value, the little, I don't know what they call it, that little fish. If the p-value is less than the fish sign, reject the hypothesis. Otherwise, you fail to reject the hypothesis. But I didn't see anywhere in there that it said it would increase or decrease.
Might be B. We have sufficient evidence that the true population is 150.
Are we on 20 or are we on 18?
18.
Oh, I was on 20.
Yeah.
Sorry.
That's okay.
So if his level of significance is lower, will that make it more scientifically valid? Because it's, I don't think it's the type 1 and type 2 error. I really don't, but I could be wrong.
But you'd think if it would make it more scientifically valid, that they would always use the 0.01.
Yeah, you would think. Where's my, let's see. Oh, here we go. No, I don't know. So we could just put something in there.
I'm checking one thing.
I don't remember any of this being reviewed.
I don't either.
If P is low, then the HO must go. If P is high, keep the guy, but that's not really what we're asking for.
I told us another one.
Yeah, I don't see it in the homework.
Mm-mm.
I'm just going to say more scientifically valid.
Oh, I think it may be type 1 error. So I just Googled which one I should use. And so if the probability that an event occurs is less than A, sigma, the usual interpretation is that the event did not occur by chance. Formally, A is the maximum acceptable level of risk for rejecting a true null hypothesis, type 1 error, and is expressed as a probability ranging between 0 and 1. The smaller the significant level, the less likely you are to make a type 1 error, and the more likely you are to make a type 2 error. Therefore, you should choose an alpha that balances these opposing risks of error based on their practical consequences in your specific situation. Usually a significance level of alpha of 0.05 works well. A significance level of 0.05 indicates a 5% risk of concluding that a difference exists when there is no actual difference. Choose a larger alpha, such as 0.10, to be more certain that you will not miss detecting a difference that might exist. So, if
So
we're
it
going, yeah. Why
increased the
when
type.
choosing a smaller alpha such as 0.01 to be more certain that you will only detect the difference that really does exist. So I would say the more scientifically valid.
Mm-hmm.
That's what I'm thinking.
That's what I put on 20.
you want me to submit mine and see if we got those right?
So what was 18?
So 18, did we put B?
We originally had put D.
Yeah. Because we do have sufficient evidence.
So it's
Because,
D.
yeah.
B.
Okay, let me see if this is right.
And what about 13? Sorry, central limit theorem. Okay.
Yeah.
Alrighty. Oh, nope. 18 is wrong and 20 is wrong.
So we know it's not B. We know it's not C. We know it's not A, and we know it's not D. I mean, A.
Which one are you talking about?
We know 20 is not D or C. We know,
I think it's B.
No, it's not B. I just put B.
Oh,
oh, you
18,
did?
18 is not B and it's not D.
oh.
Oh, I was talking about 20.
Oh, 20 we got wrong. So 20 is not C or D.
I think it's the probability of a type 2 error will increase, but
For
that's a
20.
guess. Yeah. So I don't know.
Wait. Which is A?
18.
So 18.
Because it's talking about the true population mean is less than 150.
It's got to be C then.
For 18?
Yeah.
Okay. And then A for 20?
Mm-hmm.
All right. I'll just submit it if you want me to.
Did you already fill everything else in?
Mm-hmm.
Okay.
Oh, crap. I need to go through it all over again. Nope.
And
I'll
mine's
take
not
mine.
all filled in because my computer's too slow.
All right. So A and C. Let me go. Yeah, no, I don't have mine filled in.
I'll ask my nephew. He's really good at math. So. But my meds are kicking in, so I better. I'm getting really.
Loopy.
That muscle relaxer's like really kicking in.
Well, I think we did good understanding stuff that was crazy.
Yeah. This was a hard. So I'll resubmit it.
Okay, you guys have a good week.
All right.
All right. We'll see you next week. Bye.
Bye.